Hi, my name is Quincy Howard, and I'm here with my partner, Ben Cooley, and this is our CS 2316 final project. Our final project is centered around America's favorite sport, football. The topic involves studying how errors such as fumbles and interceptions are affected by different variables such as weather conditions, the time of the season, and location. Since we found a college football CSV file, our project was based entirely off of college football games, and we discovered insight about Georgia Tech. As far as the purpose of our project, the interest actually stemmed from sports betting. Sports betting is all about predicting game outcomes. Therefore, if we find good insights from our data, we might be able to use our new knowledge to make better betting choices.
In this slide, we're showing the process of collecting data sets used for our analysis. So the first step for this was we need to find out at the end, and we needed a data set that included historical college football game data with offensive and defensive fumbles and interceptions, as well as different weather statistics like temperature, snowfall, and other things that we used. So to start this, we needed to find a large data set that provided historical stats for the college football games. And for the first data set, we found a CSV file containing games dating back for over a decade ago. And we could use this CSV file as a reference to determine what other data we needed in our other analysis. For example, we needed a data set containing locations of the college football games. And for the locations of the college football games, that could lead us to the weather. So for the location of the college football game data, we found an HTML file containing a table of every college along with their college football stadium location. And we could add this to our previous data set to find our location. And after that, we need a data set using the weather data, and we found an API that contains historical weather data for over 15 years ago. And we can plug this in and find our JSON. We added our JSON file, and we can include the entire data set. Hello. In this slide, we are showing the process of cleaning the CSV Excel file containing the football stats. The first step we had was to import the data into a pandas data frame using the pd.readExcel function. After that, we looked for inconsistency in rows. We saw duplicate entries with the same data, and also we saw that for the site of the game, some of them were unknown, and these pieces of data wouldn't be relevant for our analysis. So we dropped these, and also we had null values that we removed all the rows for. Hello. In this slide, we're discussing the process of cleaning the HTML file containing the table of college football teams and their stadium locations. So for this process, we started using Beautiful Soup, and we imported the Beautiful Soup module to parse through the HTML file, which allowed us to extract the relevant data from the table. From this, we used the find all method to find the table tags and the table rows of the HTML file, which allowed us to access the data for each team in their same location. And from this, we could strip the new line characters and get a clean city-state string for each team's stadium. After this, we dumped all the clean data into a JSON file, which can be easily accessed and used for further analysis. Hello. In this slide, we're discussing the process of cleaning data from our API. So the first thing that we need to do is we need to figure out what the API inputs and outputs were. In our case, the API takes an access key, a location, and a date, and outputs a dictionary relevant to the weather of that certain day in that certain city. Based on this information, we created a function that could be used to retrieve all of the weather data for this given day, and the output of this function is in a JSON file, which contains the relevant weather data for that day. To integrate this data with the main Excel file containing the football stats, we added the JSON file as a new column in the Excel file called API data, which allows us to easily access all the weather data for further analysis.
Before taking a look at how college football errors are affected by weather, we decided to analyze if a team having a home game or an away game has an effect on the amount of errors made. Our takeaway from this insight is that when a team is away, their standard deviation as well as their mean errors increase. Since the average number of fumbles and interceptions comes in at 1.857 for away teams, and the number comes in at 1.71 For home teams, you can say that there's an 8.5% average increase for errors when a team is away. You could also say this data proves that visiting teams are more prone to make an error. If you look at the code below, it shows that a data frame was made, and other information is gathered to create 3 new columns. The pass int off and fumbles off columns from our original data frame are used to create the offensive errors column. The same is completed for the defensive errors columns, but the errors are named pass int def and fumbles def from the original data frame. Our next insight shows how snow affects errors in football. We discovered that the average error for a snow game was 3.843, and the error for games with no snow was 3.56. Keep in mind, this average amount of error per game accounts for mistakes made by both home and away teams. We concluded that more errors occur in snowy weather conditions, and we computed a 7.94% increase when teams play in snow. The code added below shows a part of the process of how data from our API is added to our data frames. Using .extract, we gathered the specific data from our API dictionary needed to make our insights. These were things such as the average temperature, total snow, and UV index. We also used regex in order to extract the exact number of characters needed from our dictionary values. This code was used in several other insights to make analysis. Insight number 3 studies to see if UV index has an effect on fumbles and interceptions. First, let's take a look to see what UV index is. UV index measures radiation levels, and high radiation exposure is bad for the body. The exposure can cause irritation as well as damage to your skin and eyes. High UV is considered to be 8 and above, while low UV index is 5 and below. I discovered that higher UV days had more fumbles and interceptions, totaling to an average of 3.854. Lower UV days had a mean of 3.563. This is a 0.29 difference between the two totals, and you can conclude that high UV index contributes to more errors and interceptions. The code below creates 2 separate data frames, one with the rows containing high UV and the other with rows containing low UV. We added the errors for the rows in each data frame and computed the averages for both. This slide shows our first data visualization. It is a line graph that shows the amount of errors that usually occur at certain temperatures. As you can see, the graph peaks around 17 and 92 degrees, and we used our visual to conclude that higher error numbers occur at more extreme temperatures. The area from 40 to 80 degrees strongly correlates to the overall average of errors. To create this graph, we created list comprehensions that grab all the temperatures and error numbers from the data frame rows. We also added in a formula to convert our temperatures from Celsius to Fahrenheit. Next data visual is a bar graph that shows the average number of fumbles and interceptions made in every month. We quickly discovered that the month of December produces the highest output with an average of 3.923. We think this is because December games probably hosted colder temperatures, and players may feel pressure from playing their last few games of the season. These games usually lead into bowl games or even championship games. We use the first and second characters from the column date in our data frame in order to group error numbers to their respective months. The last insights and data visual provide error data about Georgia and Georgia Tech. Georgia Tech's error average is 1.71 and Georgia's average is 1.35. During this time, both teams were under the overall error number, which is 1.78. So you can include Georgia and Georgia Tech usually made fewer errors than their opponents. However, since Georgia is lower by 0.36, you can infer that they were probably the better team during this time. Our greatest challenge definitely came from finding an API with historical data. There were several weather APIs out there, but many of them didn't have historical weather, except for maybe a 7-day forecast from the previous week. However, this did allow me to learn a lot more about APIs and how they actually work, because we worked really hard to match the API best for our project. Since our API calls were limited, we also had to make sure we were very careful with executing our functions. As far as insight results, we discovered some very helpful knowledge. There is definitely a positive correlation between certain weather conditions and their effects on fumbles and interceptions. For example, now we know that high UV, extreme temperature, and snow days all increase error amounts of football games. In conclusion, it was really fun developing a stronger background in data analysis, and we know our new knowledge about errors may help us anticipate the outcome of games even before they start. That concludes our project, and thank you for watching.